shape, we can turn them into structures as well. So this is a horse stable complex, and so you can see it's all made out of nice little round logs. We make moment resistant joints, so we can make nice big portal frames. We can go up to 45, probably to 50 metre clear spans with it. That's what it looks like inside. Now, just as an interest point, the horse owners that own a lot of racing horses, because they're quite highly strung animals, they find that wooden buildings are the best to put those animals in. The steel ones, they get all jittery, they can't relax, but they put them in a wooden building like this, and they're a $3 million toy, so it's very relaxed. Houses type situation, that's sort of the structural part of how they all fit together. When you pre-make everything like this, it goes really, really fast to assemble, because everything's all pre-made. There's a little bit more of an upmarket house for it. This particular owner didn't want any visible metal connections at all, so we had to hide them all inside the pole. So we had some quite complicated joints and scallops and pins and all sorts of things. So, and that was installed probably within about a week. I think we stuck all those frames up. And that was a 1,000 square metre house, and it was for 2 people. So, we've done some joint ventures with the rent group. We were in a tender process. This was up in Dubai, and there was 3,000 houses out on the ends of those fronds. These are all houses on the water. So it was a whole year tender process. It ended up between us and a Japanese company who was going to get the job, but unfortunately they went belly up, so that didn't go anywhere. But this is one of our proposals that we had. These are 500 square metre houses, so they're quite large. We had to design for 50-ton impact loads, because every house had their own little rubber dinghy, so to speak. Sorry about the slide, it didn't come out that good on the compression, but we were in 10 metres of water. The house platforms had to be 5 metres above for global warming and that type of thing. We weren't allowed to have any visual braces, so we actually made these columns, and they're 1.2 metres in diameter, and they're just a whole lot of logs all joined together. We developed special shear connectors and things to make all that work. It needed roadways and things, so we made some pretty little interesting bridges to handle it. It's all made out of logs. The good thing about a nice log, and if you keep it round, the amount of processing involved is very minimal. We don't need great big expensive machines or anything like that. But the biggest thing is, structurally wise, it's a lot stronger than a piece of wood. In fact, it's very close to a piece of laminated timber. This is, we had to do some sort of roads across swamps and things. This is actually able to take full highway loads. So you can put, whatever the highways can take, that's what we can stick on there. It's very small and depth-wise and that type of thing, so just gives you a rough idea. Of course, it's very fast to install. We make towers, 45 metre tall ones. These, used for communication towers and things. This whole tower is a 30 metre one. It only actually weighs 1.8 tonne. So it might look like there's a lot of wood, but there isn't actually much in there. Some of the fittings that we've had to develop get quite complicated. This is an 80 kilonewton tension load moment resistant joint. So, it hasn't been done before, so we had to bend all these things, and anyway, so that worked all really well and simple. But one of the engineers that we used is a guy called Mark Batchelor from MLB Consultants, and because of these joints and that type of thing, we always have a brainstorming session once in a while, trying to work out how to make our products better and quicker and more economical. So Mark suggested 5 years ago, said, well, why don't we stick a hole up a pole, you see? And which is all really simple for him to say, but stick a hole. So before I could do that, we had to develop a pole testing machine. So we made a 20 metre long bed. We can put 80-tonne loads on it. It's fully computerised. It measures bending and measures stress. So all our structural components, we actually test every single piece. They've all got individual numbers. So we actually are stress grading our poles. It takes about 32 seconds to test the pole. they bend, of course, when you put all the big loads on them. So, and some of the big poles, the 20-metre ones, you can put up to a 2-metre bend in them before they snap.
Wow.
The good thing about these poles is it's not a brittle failure, so it's you can tell when it is going to fail. So you'll hear these the outside fibres on the pole will start snapping. So you hear this little tick, 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 and then it's just a gentle boom. But if you test a hardwood pole, then it's a totally different story. You have to tie everything down because it just goes, and then all the bits go. So we don't like testing hardwood poles. So anyway, so we worked out a way to make holes in poles. And that was a few trips to Australia to train some termites and that type of thing. So got our way going. We can drill up to 18 metres long, anywhere from a 2-inch hole up to a 6-inch hole. An 8-metre pole takes us probably about 50 seconds to drill a hole. So we worked out ways to do it pretty quick. Nice straight holes, so you can do all sorts of things with them, of course. Now, Christchurch is where we decided to stick some of these poles. And Christchurch has got multiple layers, and there's dense sand, loose, there's even sort of sandstone materials, there's logs under the ground, there's gravel layers, there's an aquifer layer around about 20 metres deep that has a 5-metre head on it. So there's all these, quite a few interesting hurdles that you've got to get across to somehow get a pole into the ground. And talking to a lot of the engineers and the geotech guys that we've been dealing with, some of the poles might, for starters you might not need some, but some of them will have to go down to 10 metres or 15, and the deepest one's probably about 25 metres. So we wanted to make the equipment as light as possible. So here's a little 16-tonne digger with a whole lot of poles with holes in them, with all the equipment that we need. And so we can turn up on a site, and half an hour later we've probably already put in 3 or 4 poles. So what we've done is we have a pole, of course, with a hole in it. We have a very high pressure jetting unit stuck on the bottom of it. The hydraulic hose is what supplies all the water to it. We just have a little special cap, and then what we do is we've modified a vibrator that sits on top of the pole, and subsequently we can just vibrate this pole in very quick. Now what happens is that in the immediate area around the pole you actually can't feel any vibrations. So a normal pole driver will, especially when you hit the hard layers, the ground can shake quite a bit. But this way you can't feel anything. So these are little small ones. We just have little fittings that we can join them up. So these fittings do have moment resistant in them, but we can make it full moment resistant joints on them. And this is just another photo in Christchurch actually with the vibrator on top. These went down I think about 12 metres, these were going down. What we do at the end is once the pole's in place, we just hook up a small pole driver on it, and then because you've got to certify that these poles can take an X amount of weight. So small poles need a small hammer, and the big 500 diameters, we use a 3-ton hammer. And then we just hit it usually 5 times, and that'll confirm the set on the pole, so it's okay. In fact, the problem here is that when you drop the monkey usually we do it at 1500 mil drop, the monkey comes straight back up again because the poles are so they're really stuck in the ground. Here's a little movie of us putting one pole in to give you an idea. There's already a pole in the ground that's 12 metres deep, and we just put in another, I think we put in another 5-metre piece on top of it. So that'll give you a rough idea, a little bit of an understanding how quick it can go on the ground. So we're only using 16-tonne diggers, so it's, the cost of setup is pretty minimal.
So you put one pole on top of the other?
Yep.
And do you join them?
Yes. So when you got a high water table, you can actually use untreated poles below the water table. And then you can just do a treated one on top. And that can save quite a bit of cost.
It's anaerobic down there.
Well, Venice is built all on untreated blocks.
Sure.
So.
Yeah, that's not the pole style.
It's not the pole style.
It's not sinking.
We have different ways of putting the poles in. This one is a vibrator on top. We also, for the big long poles, we have side vibrators that actually clamp onto the side of the logs. And we also at the moment building a little small machine that is only 2 metres high. And so the idea for that is for the houses that need new foundations in Christchurch, we can jack the house up and then drive a little small machine in and just keep adding poles until you get to the right depth. So you can see it doesn't take long. I have seen some steel poles in Christchurch. They required more than 3,000 hits to get the steel pole in the ground. The screw poles take quite a long time to put in.
I've been feeling steel ones for 3 months.
And so that pole could take probably maybe a 400 kilonewton load on it. We've done 1,500 kilonewton poles, so yeah, you're done, you're finished. That's it. And there's no damage to the pole either, by the way. Oops, another picture.
Can you explain what the water does? Is that
Cuts a hole.
That's through the hole. So is that like clearing the way as it
Yeah, it physically does cut a hole.
So have you got a fitting on the bottom of the pole that
Yes.
sacrificed them, obviously?
What we do is we have a very thin piece of steel. It's a sacrificial thing. It's got a boss on it. Our jetting unit screws into it. It's got little fancy connections on it. So once we've got it down to the bottom, all we do is unscrew it and we pull the whole hose out. So it's a quick changeover always. So that, we do have a sacrificial little piece of steel on the bottom. But we actually do need that to go through the gravels, because the gravels can get quite gnarly, you see. So anyway, so you guys wanted a nice cathedral, and as soon as I heard that they were going to put up a cardboard structure, I said, oh, that's no good. We come up with the wood. So we actually we have our own drafting team and everything else. So we drew up a structure that we could make out of timber, and we like making holes in things, and this is what we made. So we made a great big tube. It was 18 metres long, and there's no glue put in. It's got no glue in it at all. So we developed special shear connectors and things, because you need robots to make this type of stuff. So you have accuracy of 0.001 millis when you make these things. So it was 800 diameter, and it was a lot cheaper than the cardboard solution. I think that whole structure was only about $400,000. And but
that's
anyway,
that's 10% of the cost of cardboard.
yeah, I know, but they just want to look at it. They said the cardboard had some airy-feely, nice, touchy things about it, and I see in the paper the other day they're putting LVL up the cardboard tubes because they don't work anyway. So anyway, yeah, so we had a nice solution, and what we were even suggested to them that every alternate piece we could have put a native piece of timber in to make it actually look, quite interesting. So anyway, but they wouldn't wear it, so that was that. We're also presently designing quite a few multi-storey buildings using our round logs, because we can put a reinforcing rod, same as this post-tension idea type thing, which has always been around for a while. So and that way it's also totally fireproof, and we're just using our nice uniform line with the round logs to hold the whole building together. But under all our computer designs and stuff, we've been able to actually get total base isolation on every single layer. Normally you can only do it on the bottom story, but we've been able to do it on every single layer, so that actually gives you more advantages for construction costs and that type of stuff. We have there's shear walls in there. You see these on the left hand side there, and that's roughly what they'll probably look like. And the holes, of course, to put the reinforcing cables up. We also plastic spray the poles too. So use a product that's a polyurethane product, and we basically just literally spray it on the poles. But it's a product that's been around for a while, and it can actually can last for about 75 years. And this is what we were going to use on that Dubai job, because we had to guarantee these poles in the ground for 100 years, and it was the only way we could actually theoretically be able to do it. So that's just a plastic pole in the middle of the river down from our yard. So that's it. Any questions?
Yeah, did you get a resource consent for that pole?
Yeah, no, we got one of those. I know the council well, so it's a piece of cake.
Just the poles and stuff, I'm not a forestry person, but are they all pine?
Yes.
It's all softwood and hardwood.
Yeah, you can't use hay. No, or you just can't get the volume, you can't get the right size of seat, it's all softwood. Yep.
Can you pull on those poles as hard as you push on them?
Yes.
So the loads work in both directions?
Yes. Down the hole we put we usually fill the hole up with, just a grout and a reinforcing rod,
Yep.
so that can give us our tension loads. That's all designed for to go both ways.
How do they perform in the ground when it starts shaking?
And what I mean, they're down to the regular gravel layers. Usually that's where they sort of end up. So that's the geotech guys say how far we have to go down, and that's where we put them down to.
What sort of lateral strength do they have?
Well, they can bend quite a bit, you see, so they can take quite a lot of lateral movement. We have standard charts on how much they can take for different situations. So they work really good in the TC3 areas and close to the rivers and stuff. So.
Wonderful, John. I love them. Tell me about what you say now when people don't want tanners in the ground and the you're saying only treat the top bit?
Yeah, you can just use only the top piece, and you can just have untreated poles underneath. We've done that in the North Island a lot. But I mean, the CCA is, it's a natural product.
I know, but
it's everywhere in the ground. And
there's certain people that don't want it, or there's living building challenge that won't allow it.
That's true. You can use copper-based chemicals if you want to.
Yes.
They cost about 4 times more.
Yeah.
So so if they want to do that, and pay that difference, that's fine.
And it only need to be for that section. That's
correct.
That's got the
that's
oxygen.
basically sort of about 2 to 3 metres below the water table and above.
Right.
Yeah.
And in Central Christchurch, where we are, the years we've done the testing, the water table's between 1 and 2 metres below the surface, so you don't need to do much at all.
No, you don't. There's not much in it. No.
Yeah.
But you still got to get the engineers. They're the ones that still have to sign it off. So somebody's got to issue a PS1 to, then sign off the job at the end of the day.
You may know, but I've just seen these somewhere before. We're going to use them for the new theatre here in town, are we not?
Yes.
Right. That's a good practical example for us locally.
Yes. Yeah, you're 72 poles to put in here. Yeah. The situation here is I think they did some test piling or something, and they used conventional equipment, and one of the neighbouring properties settled. So
Yeah, they're worried about the clubs next door moving, banging in poles.
Yep. So we got to come in and do it in the middle of the night so nobody can feel us. Yeah.
With the holes through all of your poles in the multi-storey buildings as well.
Yeah.
Apart from reinforcing or tensioning, is it possible to run services through those holes?
We on the bigger poles here we've got quite a big hole. So if as long as there's no cable, post tensioning cable in there, no worries. Then you can put things in. The hole actually doesn't affect the strength of the pole at all. It's got 0 effect.
Do you have trouble getting poles from the forest that people growing? Don't have trouble.
Yes, where we're situated, we're actually quite lucky because we probably have about more than half of New Zealand's forest resources within about a 300k range. And with poles we pay a lot more than your normal domestic logs. So we can actually pull them in from a bigger distance.
We try to produce them here, but we find that the specifications are so restrictive that it's hard to produce many poles from our stands.
Depends what the pole gets used for. So there's different criteria that we use. If it's a foundation pole, we can handle a little bit more sweep, not size on them. If it's more of a structural one, or if it's inside a building, then the spec gets a little bit tighter. But we sort a lot of those out in our yard, you see, so we can work out which goes where into which product. But yeah, unthinned, unpruned forests are the best for us. Yeah.
So presumably with a hole in the middle, your treatment, where you do have to use the filthy treatment, excuse me for the people that mind, you're getting better coverage. So
You actually get full penetration.
Yeah?
Yeah.
So you can hack away with
You can do whatever you want with it.
and you know that you're not getting untreated.
Yeah. 'Cause normally when we treat a pole, if we don't have the hole in it, it's the heartwood we can't actually treat very well. Some we can, some we can't. But yeah, with the hole in it, it goes both ways, and plus the hole actually removes quite a bit of that hardwood. So,
What sort of accuracy do you get with your hole?
depending which product and where it goes for different reasons. Yeah, no, we can do it very accurate.
You can.
Do you want to do an update on the price? Back in February, when I got you to do comparative
Yep.
price of the concrete poles, we had the 30.5 metre, and you came, the timber ones came to a third of the price.
And we're cheaper now.
Yeah,
Yeah.
Yeah.
Think compared to a concrete or a steel
Yeah.
or a screw pole.
yeah, cheaper than the steel.
No, by a long shot.
I've been suffering every 12 seconds for the last 3 months. Steel poles being whacked in, so it'll be a nice change.
Have you built any of those bridges? Are many of those in use in New Zealand?
No.
No. How would they compare to the price of concrete bridges or concrete steel structures?
Very favourable.
Because obviously in forestry we need a lot of temporary bridges across cold, small streams and that sort of stuff.
Yeah, in that case, it depends on the span and stuff. That's the cheapest way is just to stack a whole lot of logs on top of each other. Yeah, and we don't use glue or bolts. We actually make a special shear connector, so we cut slots across the pole and they all clip together. So that's how that tube was made. So there are actually lots of slots down the whole piece of wood, and that tube was tapered as well. So yeah, so it's a bit of 3D looking at that.
You're getting, you're having trouble with architects and other people that use this sort of type of products?
We actually have no sales staff.
Pardon me?
We have no sales staff.
No?
All right, so it's just people come to us and ask, can you do this or do that type of thing. We haven't actually approached many architects at all in Christchurch yet. We've spoken to a few engineers and geotech guys, like Hawkins and that type of thing, and they're very keen on using it.
Can you go and talk to the Nelson branch and work on, please?
I don't mind doing it.